Hello, programmers. Today, this is going to be like tutorial 4, maybe 3.5. I don't know what I'm going to number this. I think I'll call it 3.5. This is another slightly more advanced example program that I'd like to show you guys. This is a multi-threaded program, and what it does is it runs some threads that push integers onto this vector, right? So this is a demonstration of using a vector. It's a demonstration of using multi-threading and mutexes and stuff, you know. And so I just thought I'd show you guys this. So here from main, what we do is, first of all, we call the constructors on our 3 vectors: threads, targ, and thread stats. We don't actually ever call the destructors of these, but it's fine, right? The operating system will clean up after us. We construct them. We make the mutex for the target vector, right? This is where our integers will be pushed. This is the mutex. If the target mutex is not allocated, we return 1. It clearly failed. This is the number of threads we want to create. We could create 20. We could create 100. You know, let's bump it up to 20, right? See what it does this time. Here we go, right? So now it's pushed quite a lot of crap onto the vector, but anyway, that's not important. I also print here. I probably should remove that, right? The thing is, that was for debugging. Let's rebuild. Right, so we create the threads, right? Thread new. Then for each of the threads, we allocate a thread data struct. This is the thread data struct. We assign some variables to it. This is just saying how the thread is going to behave. And then we push onto thread stats, which is a vector of these structs. Well, pointers to those structs, right? We assign the argument here. We assign the function for the thread, and then we start the thread. This starts the thread in the locked state. So, you know, like, actually, if print working, and then we run this, we should clearly see that immediately before we see anything here. Scrolling up. I'm just explaining how the threading library works. It's based on Pthreads. It's an implementation based on Pthreads. This threading implementation I call lockstep thread. The reason is that it was originally designed for game engines. See, threads are done. Here's the threads working. Oh crap! Maybe I didn't think this through. See here, we do running threads, and then they're working, right? They're working never gets called before running threads. So thread start does not actually ever cause these things to be called, right? And you'll notice that because of this printout obviously is not thread safe, so eventually there's going to be races like this. I'll just remove this for you for running purpose. We don't need to debug that. I just wanted to show that this here does not cause any threads to run. This right here is what this is what causes threads to run, right? So we are in this while loop here, and basically what we do is we go through the threads, we step them all, then we go through and lock them all. Lock means that they're no longer running. Their function is no longer running. Then we check if they're done, right? If any of them are not done, we go to this label here, which will go through the loop. Otherwise, we break. Then we say threads are done, because they're done. Then we go through and we kill the threads, and we delete them. Those are 2 separate actions. Thread start and thread kill are inverses. Meanwhile, thread delete is the inverse of thread new. Then we print the results. This is the vector. This is that huge vector that gets printed out. It's this stuff. This is being printed. Hold on. Where were we? Here, right? And that's the program, right? So this is another simple program that uses more advanced features. I thought it was important in this tutorial series to cover and to show you that multi-threading is possible in Coder's Basilisk, and I wanted an example which is easy to understand how to manipulate. You can experiment with this, you can try changing things and see how it works. Here's the multi-threading library in the code. If and def CBAS single threaded, right? There's a version of the multi-threading library that that is implemented just to provide dummy functionality in case the host does not support Pthreads. But here you see thread new, thread delete. This is all stuff that works with my ls thread library, which I wrote a long time ago. And then here's the single threaded dummy functions that just thread step just calls the function. If we go up to the top, I believe that's where I have my ls thread library. See, this is Pthreads, right? We have a mutex and a barrier and stuff. I wrote this code a long time ago. To be honest, I'm not actually sure if this stuff is airtight, but it's worked every single time that I've tried it, right? It could be that it's, I know that mutexes and barriers and stuff are a little slow, but it works for my purposes, right? And to be frank, if multi-threading is worth it in your application, I think this implementation is probably sufficient for you. This is a very nice implementation that is somewhat battle tested. I haven't written that many multi-threaded applications, to be honest, but every time that I've written one with this library, basically since I finalized it, since I finished it, it's been working. So anyway, and you can read through this if you want to see these. If you're a Pthreads expert, you can read through this and see my old multi-threaded code that I wrote when I was a teenager. Because I wrote this years and years and years ago, and I just imported it into my standard library here. The major things that you need to pay attention to for learning purposes are, first of all, this is how Coder's Basilisk does templating, right? Templating was implemented through compile time code, by the way. It's not part of the base level language. The templating system that I designed into the standard meta library works this way, right? It's actually part of standard. No, templating is part of standard meta, but this vec is actually part of standard ext, right? If you go to coders_basilisk/library, it's in standard ext is where the vec is, right? If I scroll down, vec will be here. This is vec s, this is vec c, and here's vec, right? This is the implementation of vec. What vec does is it basically just expands out into vec c, vec p, or vec s. This is the runtime implementation of the standard template library. I have vector and unique pointer, and I'm not sure if I have anything else other than that, because to be frank, I don't really ever need anything. New, I have new. And new b, I don't remember what new b is for. New calls ctor, and then new b does not call ctor, okay. Okay, that makes sense. Anyway, so this is a little program which demonstrates templating. It demonstrates multi-threading, obviously. It demonstrates a heavy amount of using C code, right? This is quite advanced C code that we're using here, right? And it's being used with Coder's Basilisk. If you're familiar with Pthreads, you know that it is a fairly terse library as C libraries go, at least in my opinion, right? Compared to most C libraries I've worked with, Pthreads is a very complex and very terse library. POSIX threads. And so this is a good example, right? Other things that this is demonstrating that you might not have seen before. You're clearly seeing how I'm using malloc and free. You're seeing how I use get fnptr. We don't use call fnptr here because we do that inside of C. We call that's what we call the function pointer. This is demonstrating, fprint. This is a thing from the standard library in the user mode standard library, fprint. So I'm demonstrating that here. And if you want to, you can go through the standard library, right, and you can find where I defined fprint right here. Right, it's just an alias for pprint using prints and I to A. Here's prints, you know, and you can find I to A somewhere around here, right? I'll go through and I'll go. This implementation here, I'm pretty sure is probably bugged, so I'm probably going to this f2a underscore a implementation. I'm going to fix this sometime. I'm not actually sure that it's bugged, but I think I remember that when I tested a C version of this, it didn't quite work right. So I'll probably just make this be an alias for the C f2a. But anyway, that's unrelated to this example, right? In this example, we're just working with integers and we're printing yeah, so anyway, I know that this was a bit rambly and distracting. We talked about F2A for some reason. I recommend, if you want to understand this example project, by the way, let me push this to GitHub. Git init, git branch -m main, add dot git commit -m initial. I'll call this tutorial 3.5. Let's do the remote adding. Git remote add git at codeberg.org :deck / multithreading underscore example. Oh, need to do add origin. This should work. All right, and so now this should be, yeah. By the way, I think I've neglected to mention, but these examples are in the public domain. I fully released them to you under the CC0 license, right? In fact, let's make that formal, right? There we go. So now they're now it's this one's public domain. There you go. So anyway, if you have any questions, by the way, about this example, if you think it's confusing, because this is quite an advanced example, right? Pthreads is a very complicated library. It's quite involved, and I do expect that lots of C programmers probably have never even worked with multi-threaded code before. And while by implementation does simplify working with threads quite a bit, right? You just you hand a function and a byte pointer to a thread object, and then it just sort of magically runs it, right? That's how I've made this API work, right? If you find this confusing, if you find this hard to understand, write some comments, right? Ask me how it works. I usually respond to comments when I see them, so feel free, right? And if you're angry, you can yell at me. Although I tend to prefer the nice comments. I usually get nice comments. You guys are usually nice. So that's about it for this video. Yes, and here's where we do the printing, right? Obviously. But I hope you guys enjoyed. Thanks for watching.